Hi to all. So today our topic is experimental determination of XD and XQ, or it is also called as slip test. So what is XD? XD means direct axis reactance. XQ means quadrature axis reactance. So this is the one experiment in the machine lab actually. So this is the complete circuit diagram of slip test. So this is the complete circuit diagram of slip test. So this is the DC motor setup and this is the alternator setup. So simply this DC motor is coupled with alternator. Here DC motor is coupled with alternator. This is the symbol for coupling symbol. Okay, in this DC motor, so in the DC motor having two windings, you know already, armature winding and field winding. So this is the 3-point starter L, A, Z. L means line, A means armature, Z means field. So this is called 3 points are there. So that's why this is called 3-point starter. So here this supply is given. These two are the fuses. Next this is the rheostats. This is the armature winding. This is the field winding. So finally DC motor output is mechanical energy. So here we are giving some electrical energy is converting to mechanical energy. So this mechanical energy is coupled with the alternator. So alternator input is mechanical energy. So we want mechanical energy. So in this setup, so this is the stator. This is the rotor winding of alternator. This is the stator winding. And this is the rotor winding of alternator. So here this is the 3-phase variac R, Y, B, 3-phase variac. This is the 3-phase stator winding R, Y, B. Here this is the voltmeter and this is the ammeter. So here just apply the 3-phase 440 volts supply. Here 3-phase 440 volts supply is applied. So this is the complete circuit diagram. So in this heading, experiment means actually this is the one experiment in the machine lab. So slip test. So actually first we have a doubt. Slip test in the synchronous machine or in this alternator, why you got slip? So initially NS and NR both are same. So that's why in the alternator you got slip values generally 0. But here we are conducting slip test. Why means, so in this concept, slip test concept, or one more topic is there, that is a two reaction theory. Two reaction theory concept means, so here this is the rotor winding, this is the stator winding. So from the basic of alternator, generally rotor winding is excited by some DC source and some mechanical energy. Then EMF will be induced in the stator winding. That is the main basic concept of alternator. But here in the slip test or two reaction theory, so we are not exciting the rotor winding to the some any source. So we are not applying, we are not exciting the DC source. Just applying the AC source, some reduced voltage is given to this stator winding. Then EMF will be induced, some small EMF will be induced in the rotor winding. That is the main concept of this slip test or two reactance theory. So what is the concept? Just some reduced voltage is applied to the stator winding. So simply this field winding is simply open circuited. So only stator winding applied some reduced voltage. Then finally you got some EMF in this rotor winding. So that is the main concept. So here why slip means, in the basic concept, induction motor also, so simply stator winding is given to some 3-phase supply, and that stator winding will cut the rotor winding. Then EMF will be induced in the rotor. So finally in the rotor side you got some slip frequency. So what is the slip? Slip means the difference between the NS means synchronous speed and the rotor speed, that is the slip. Slip means, so slip speed or slip means, that is the formula is NS minus NR. ns minus nr by nn, that is the slip formula. So here we are taking the some small slip means 1%. So here 1% means 1 by 100 means 0.01 slip. So from the basics, you know one formula, nr is equal to ns into 1 minus s. ns means synchronous speed. Synchronous speed generally from the 120f by p formula you got the 1500 rpm. 1 is the same minus s means 0.01. So finally you got the 1485 rpm speed. 1485 rpm speed. So here the rotor side you got the 1485 rpm, but in the stator side you got some 1500 rpm speed. Then finally you got the some small slip. So that's why this name, experimental name is the, you got the slip test. So nr means rotor speed. Rotor means, so rotor inputs from the DC motor. Okay, you got some 1485 speed from this rheostat. So in this rotor winding, in this stator winding, you got some speed. How much speed? 15 rpm speed. So finally you got the difference between these two speeds. You got the slip. So that's why you got the slip test. Next, what is the procedure? To find XP and XQ? So this is the first. This is the DC motor and this is the alternator. First check the rotation of this DC motor and this alternator. Check the directions. So if suppose this DC motor rotation is clockwise, this alternator rotation is anti-clockwise, so you got some problem. So that's why first check the rotation. So first supply is given to the only DC motor supply by using some DC source, DC 20 volt supply. Then by using this rheostat, then simply start the experiments. So here just switch on the motor by using this 3-point starter. So slowly run the motor. Just observe the direction of this motor. If suppose clockwise direction, then okay, leave it, no problem. Then switch off this DC motor supply. Then come to this alternator. By using this 3-phase voltage, just applying some small voltage. Just observe this rotation of this alternator, clockwise or anti-clockwise. Then this one also clockwise direction. Then no problem, both are same direction. Then easily perform the experiment, no problem. If suppose this alternator direction is reverse, then simply change the any one phase sequence, RYB, any one phase. Just simply change the any one phase. Then you got the clockwise direction. So this is the alternator clockwise direction. This one also clockwise direction, no problem. So this one also, then switch off the simply supply. Then come to starting. So what is the procedure? Procedure means first point, as per circuit diagram given the connections. Next, first simply apply the DC voltage 20 volts by using this starter. Next, after that, so here 3-phase voltage. How much voltage is applied? Not directly 440 volts. Just to 10 to 15% of rated voltage. 10 to 15% of rated voltage means simply some 68 volts around, some 60 to some 70 volts around. Just apply the by using this 3-phase variac. First, initially this 3-phase variac position is 0 position. This one 3-phase variac position is 0 position. First of all, check once this one and this one. Rheostat is minimum position and 3-phase variac also minimum position. Then switch on the experiments. So here 3-phase variac is 0 position. Okay. By using this 3-phase variac, just slowly vary the 3-phase variac. So in this voltmeter, just apply the some 10 to 15% of rated voltage, means some 60 to 70 volts apply in this voltmeter. Then observe the ammeter value also. So you got some value here also, some value. Then So this field winding is simply open circuited or by using some multimeter. By using some multimeter, by using some multimeter, you have to observe. Otherwise, simply open this field winding. Just observe this voltmeter and this ammeter. So next is a very important point. So in this rheostat, so you got some speed by using NR calculations, 1485 RPM. So in this 1485 RPM, by using this rheostat to set the 1485 RPM speed by using this rheostat. Then in this voltmeter, you got some oscillations. So here first starting value means, for example, this is the 0 to 150 volts. So here 0 to 10 amps ammeter. So here you got some minimum values, some 60, maximum values some 64. So the 60 is the minimum value. So in this voltmeter you got some oscillations, 60, 64, 60, 64. Next in this ammeter you got some approximate values, some 4 amps and 7 amps, 4 amps, 7 amps. So you got some oscillations, 4 amps to 7 amps, 4 amps to 7 amps. So this 4 amps is the minimum value of current value. This 7 amps is the maximum value of current value. So what is this 7 amps value means? This is the alternator full load rated current value. So this is the display in the nameplate details. You have to observe in the nameplate. You got you have to see the in the values 7 amps. So by using this rheostat, you have to set the 1485 RPM. So here you got the oscillations. Here you got the oscillations. So from these oscillations, you have to note down the minimum value and maximum value. So in this table column, maximum value means you got some maximum value in this voltmeter only, not in this voltmeter, only in this voltmeter. Maximum value approximately 65 volts you got. So minimum value you got 64 volts from this voltmeter, minimum value and maximum value. From this ammeter, maximum value and minimum value. So these are the values. So what is the use of this one means? Just observe without applying any excitation to the rotor, then some EMF will be induced. So approximately by using multimeter, you got some 12 volts. 12 volts means, so what is the meaning of this one means? So in the two reactance theory concept, rotor winding is aligned with D axis. This rotor winding is aligned with D axis. You got the volts, 12 volts. Okay. Next, from these values, V maximum and V minimum, I maximum and I minimum values. So you know already formula XD is equal to V maximum by I minimum. V maximum means 65 volts. I minimum means 4.5 amperes. XQ means V minimum by I maximum. V minimum value means 64 volts. I maximum means 7 amps. So finally you got the XT and XQ values from this slip test. Okay, this is the experiment in the machine lab and experimental derivation of XD and XQ. Okay.